All right, here is your semester exam review, the second part, the first page, front and back. Number 1, given A is at 2, 2, B is at 3, 5, and C is at negative 5, 2, which coordinate will make segment AB parallel to segment CD? So this is similar to the ones we were just talking about yesterday, the last one we looked at, but instead of perpendicular, this time we're looking at parallel, which means the slopes are going to be the same. When I look at my first line, if I go up, my slope up 1, 2, 3, my rise is 3, and then I run just 1. Your parallel slope, the slope that's parallel is going to be the exact same thing, 3 over 1. So from the point that they gave me, I'm just going to go up 1, 2, 3 over 1. Or I can go down 1, 2, 3, back 1, down 1, 2, 3, back 1. So here is my parallel line. I want to know which of my answer choices is in the same exact, is on that line. Okay, so when I look starting with F, F is at negative 3, 4. So that's answer choice F, not on my line. G is at negative 2, 1, negative 2, 1. Here is answer choice G. That is not on my line. H is at negative 4, 5. Negative 4, 1, 2, 3, 4, 5. There is answer choice H, which is on my line, so that is my correct answer. All right, let's look at number 2. Number 2, same thing. It's the same type of problem. I need to look at my slope of my given lines or segment. So up 1, 2, 3, 4, 5. My slope has a rise of 5 and a run of 2. My parallel slope then will be the exact same slope, okay, 5 over 2. So from my second point, I'm going to go up 1, 2, 3, 4, 5 over 2. Up 1, 2, 3, 4, 5 over 2. Or I could go down 1, 2, 3, 4, 5 over 2. So here is my parallel line to that segment. So starting with answer choice F, negative 4, positive 2. There's F. That is definitely not on the line. G is at negative 2, 1. Here is G. Again, not on the line. H is at 7, negative 1. H is not on the line, so hopefully D will be on the line. 4, 2. 4, 2. There is D. Or J, which is on the line. Point D, J on the line. Okay? Number 3. Find the measure of angle 1. If I look at just on this triangle, I look at the triangle just on the left, and I look at the fact that it has an exterior angle, and that's the one that I'm trying to find. Okay? I'm trying to find this exterior angle right here. If I look at just that purple part, remember we did an activity where we tore this piece off and we glued it in here. And then we tore this piece off and we glued it in here and we said, oh look, they fit exactly. All I need to do is add, to get that outside angle, the 39 plus the 58. When I add 39 plus 58, I get 97 for that outside angle. And it's an angle, so it's degrees. All right, number 4 and 5. Find each angle measure in the diagram below. So same thing when I look at number 1, when I'm trying to find angle 1, if I look at just this purple triangle, okay, remember we can tear off the 70 and glue it in here. And we can tear off the 55 and glue it in here. And together they make that whole angle. So for angle 1, it's going to be 70 plus 55, which will give me a measure of angle 1 of 125 degrees. Okay? For angle 3, I'm going to go ahead and use my eraser so I can start with a fresh picture. So that's why, again, it's math. We like erasers. So angle 3 is in this triangle over here. Didn't outline that very well, but that's okay. I know that if this angle here is 55, this one is also 55 degrees. Okay, so then I'm going to look at the same thing I did before. I know if I take this 55-degree angle and I glue it out here, and I take angle 3, whatever it is, and I glue it out here, I know that together they'll make this angle here. So my 55-degree angle plus that angle 3 that I don't know, that I'm trying to find, together will make 150. So how do I figure out what x is? I just need to subtract the 55 from the 150. Subtraction property of equality, x gives me 150 minus 55 is 95 degrees for angle 3. All right, number 6. Suppose triangle ABC is congruent to triangle DEF. Find the value of x and find the value of y. If I look at x, here's the where I see an x. The problem with this one is I have an x and a y. I can tell you that EF matches with BC, so I do know that that expression equals 90.6. But that's not going to help me until I know what y is. So let's skip to number 7 and look at y. I see a y right here at angle D. So when I look at D, D matches with A. A is 65. So that means that 2y minus 5 equals 65. So the first thing I want to do is subtract or add 5 to both sides. I end up with 2y equals 70. So then I divide both sides by 2. And y equals 35. So now if I know what y equals, I can plug that 35 in right here. So I've got 2x plus 35 equals 90.6. Okay, so I'm going to actually move my picture this direction so that I have some room to do that algebra. Okay, so I know that 2x plus y makes 90.6. I found y to be 35. 2x plus 35, I used substitution, equals 90.6. I'm going to add 35 to both, or sorry, subtract 35 from both sides, subtraction property of equality. When I do that, I'm left with 2y, that's a y, equals 90.6 minus 35 is 55.6. I'm going to divide both sides by 2. And I get that, ooh, sorry, that's supposed to be an x right there. And I get x equals 27.8. So x equals 27.8. Okay, and just so we can kind of see the whole thing at one time. All right, number 8. Determine which postulate can be used to prove that the triangles are congruent. If it is not possible to prove congruence, write not possible. Okay, so I'm going to zoom into each one. When I look at this first one, remember I said use your highlighter, use your highlighter. I highlight one triangle. I can see that this side here has a single tick mark on it. This side has a double tick mark on it. And then this side is my reflexive side. I've highlighted 3 sides, so that makes this congruent by side, side, side. Let's look at number 9. You do have to read if it has directions for you. It does say that EG is this one here, bisects angle DEF. So DEF. This green angle is being bisected. So what that tells me is it's being cut into 2 equal halves. Okay? So then when I go back to my highlighter and highlight things I know, the only side I know anything about is the reflexive side. I know I've got that one side. Okay? So then what I'm going to do is I'm going to look at my angles, and I see an arc mark right here that matches the arc mark down at the bottom. And then we added this arc mark because of my bisecting. So I can see 2 angles marked, and I can see one side marked. So I have to decide, is this, I've got 2 angles and a side. So is it AAS or is it ASA? So look at where your side is. Is the side connecting the 2 angles? Is it in between them? No, it's not. So my side is not in between the 2. We're right here at angle, angle, side. Okay. Number 10. If triangle ABC is isosceles with vertex angle B and angle ADB is right, then mark everything you know to be true of the angle of the triangle on the figure below. Okay? So when I look at the figure, if it's isosceles and B is my vertex angle, I know that these are my congruent legs, which means I also know I have congruent base angles. Okay? It also tells me angle ADB is right. ADB is right. So now what do I know about this picture? I know that AB is congruent to, well, it has a tick mark, it's congruent to BC. Okay? I know that CD is congruent to, well, if I have 2 angles and a side, my 2 sides are congruent. So by AAS, angle, angle, side, I know that, and then by CBCTC, CD will match AD. Okay? And then angle BDC, that's the right angle here. So it's congruent to the other right angle, BDA. And then the next thing it says is point D right here is a what? Point D is a midpoint of AC. Angle ABD, ABD, there's the bell, it got me. That's not your bell, that's a bell because I'm at school working on making this. Angle ABD is congruent to the side next to it, CBD. And the last thing it asks me is for the measure of angle BAD, which is, and what it's congruent to. So BAD is this outside angle over here, so it's going to match with BCD. And again, all of that is because I can show that these triangles are congruent by angle, angle, side. All right, number 12. Number 12, what are the missing coordinates of the triangle below? So again, we have to use what we know about the fact that these are isosceles triangles on the coordinate plane, okay? So I know if I'm going to go 2B this direction, I'm going to also go 2B in the opposite direction, and on a coordinate plane, when I go on the negative direction on the x-axis, that means I'm going to go a negative 2B. And since I'm still right here on the y-axis, I haven't gone up or down anywhere, my y value is 0. Negative 2b, 0. Okay? When I look at the second one over here, it's kind of similar, except we've moved our triangle over. It's still an isosceles triangle, and we went 2p this time, this direction. Now remember all of those fancy things we learned about isosceles triangles, that if you were to draw in the altitude, it's going to divide your base in half. if all the way across from A to B is 2p, then halfway across is going to be 1p. Okay, so that makes this x value just 1p, and the y value they already gave me was q, so that one is pq. Number 14. Mark the picture below with everything you know to be true if you have a median. Okay, so a median, the only thing I know about a median is that it starts at a vertex and it ends at a midpoint. So if W is a midpoint, that means it's dividing a segment into two congruent pieces. That's all I know about this picture. I don't know anything else. Okay? Number 15 says I have an angle bisector. The only thing I know about an angle bisector is that it bisects an angle, cuts an angle into two equal halves. So it says XY on this one, but it means YW. Okay? So if this is an angle bisector, then it's cutting an angle into two equal pieces. Okay? And that's, again, the only thing I can mark in this picture. That's all I know to be true. Okay? And then on the last one, again, it should say YW. Sorry for that typo. But looking for an altitude, and again, I want this one to be my altitude. What an altitude does is it starts at a vertex and it ends at a 90-degree angle. So that's all I know about this picture if I have an altitude. Okay? Number 17. Number 17 says to write an inequality to describe the possible values for the measure of angle x. Okay? Well, actually, looking at this picture, I don't need to write an inequality. I can figure out exactly how big x is, because I remember we tore off this corner, remember, and we glued it here. And then we tore off this corner and we glued it here, and we saw they made exactly that exterior angle. So I can take this problem and I can, in order to find this exterior angle, I just have to add the 34 plus the 42, which gives me a value of 76 degrees for angle x. All right, number 18. Number 18, write an inequality to describe the possible values for x. Now this one I do have to give an inequality. And just in case you have forgotten, we say that 0 is less than the interior angle, the non-adjacent interior angle, which is less than the exterior angle, which is less than 180. Okay, so then I'm just going to start plugging things in. So my 0 is less than the interior angle, the one inside that's not next to the exterior. So that's x. Is less than the exterior angle, that's the outside one, is less than 180. So then my question becomes, what does x have to be in between? X has to be in between 0 and 15. So I just need this part of the inequality for my answer. Okay, number 19. Can the following three numbers be used to make a triangle? Okay, if I know two sides of the triangle and I can find their difference by subtracting them, and I can find the sum by adding them, I know that my third side has to be greater than the difference but less than the sum. It has to be right in between, somewhere in between. It's not allowed to equal the difference. It's not allowed to equal the sum. Okay, so to find my difference, I'm just going to pick two of my sides. I normally just go with the first two, but you pick whichever two you like. Okay, so the difference of 24 and 32 is 8. The sum, when I add them together, the sum of 24 and 32 is 56. And so what I need to decide is 50 in between 8 and 56, and 8 and 56, and we say yes, it is. So yes, I can make a triangle. Or yes, with those three sides. Okay? Number 20. Number 20 is just a little different because I have square roots. So that just means you're going to want to use your calculator, because I don't know about you, but I don't know what the square root of 5 is off the top of my head. I know it's a little more than 2 because the square root of 4 is 2. Okay? I know it's less than 3 because the square root of 9 would give me 3. But I don't know off the top of my head. I'm still going to take these two, though, and I'm going to type them in my calculator, and I have to make sure that I exit out of the square root in between typing each one, so you'll want to practice typing that in, okay? When I find their difference, I get 0.4096, and it keeps going on and on and on, but just to kind of round it. And then when I do the sum, when I add those two together in my calculator, I get a big decimal, but it's 4.882 something something something. And I just need to know, is the square root of 13, does it fall in between? So when I put that in my calculator and get a decimal, I get about 3.6, and it's 3.6055 something something, okay? So does this fall in between 0.4 and 4? Yes, it does. So I can also make a triangle with number 20. All right, 21. Write an inequality to describe the relationship between the lengths of BC and DC. So if I don't look at the whole triangle, if I just look at part of the triangle, if I refrain myself to just this triangle, hopefully you can see that classifying this, I would classify it by its angles as a right triangle, which makes this side a hypotenuse, and it makes this side a leg. And we know that the hypotenuse is always greater than the leg. So in this case, I know that segment BC is greater than the leg DC. Okay? You could also write this backwards. You could say that the leg DC is less than the hypotenuse BC. So either one of these, you could write it either way. The hypotenuse is greater than the leg, or the leg is less than the hypotenuse. They're both correct. All right, now we'll go ahead and start part 2, or the part 2 of part 2, if that makes sense. And we'll finish up our review for our exams next week.